Hi to all, welcome to Algotech Programming Concept. In this video lecture, I am going to discuss all three cases of arbitrary by taking one example. So that you will easily understand all the three cases in which scenario will be applied to balance the tree. So this is the example where this is a tree you can see here in this slide, and all the arbitrary properties meet here, means all the arbitrary properties is existing here. Okay, if we insert key 4 in this arbitrary, okay, so the tree will be unbalanced. Here we can see that, and after insertion of key 4 we will apply it that it is case 1, case 2 or case 3. Okay, so when we have inserted key 4 in this arbitrary, so the value of 4 is 4 will be placed at left side of this 5. So first 4 will be compared to root node. So insertion is just like as binary search tree where we did the insertion. So this 4 is placed at the left side of this key 5. Now the case 1, case 2 and case 3 happens when the color of P of G, means when the color of the parent key is red. So 4 is newly inserted node, so the color of newly inserted node is red, and the color of parent of this node 4 is the color of parent of this node 4 is red. So we have to check either it is a case 1 or case 2 or case 3. So in case 1, if the color of uncle is red, if the color of this newly inserted node uncle is red, then it will be case 1, and we have to make black color to P of G and uncle, and we have to color the grandparent as red and make it G. So here you can see that. So when all the cases will be tested when the P of G is red, so this is a G is a newly inserted node, P of G is 5 and P of PG is 7. So and the color of uncle means Z's uncle is red, which is display here as Y. So this is case 1. So case 1 is that when P of G is red and G's uncle is red and P of G is left side or right side, we will see in two cases. And so we will make P of G and uncle as black, and P of G means grandparent will be red, and make it G node. Because the root node is always black, so again we will color as black node. So this is case 1. Okay, so in the example part, that was a case 1, that what happens in case 1. So in example what we will do, that we will make P of G and uncle as black, and we will color this node number 7 as red and make it G. Okay, okay. Oh, and this is not a root node, so and we have not to do anything more. So this is case 1. Now you can see that this is our node G. Okay, and we have to check that what is the color of P of G. So node number 7's parent is node number 2, and the color of node number 2 is red. So whenever we will get the P of G is red, so we have to check for our cases. Now check what is the color of uncle, what is the color of this node number 7, what is the color of uncle of this node number 7. So the uncle's color is black. So now we will move towards either case 2 or case 3, and this node G is right side of its parent. Okay, you can see here, this is a G, this is P of G, and this is uncle, and this G is right side of its parent. So here case number 2 will be happen. So in case number 2 we will make PG as G. Okay, and we have to make here left rotation. Okay, so this is case number 2. What is case number 2? If G's uncle is black while color of PG is red, G's uncle is black and J is right child of its parent. This is right child of its parent. Then we will make PG as G, and we will make left rotation on this node G. Okay, so in this example, we have to make left rotation on this G. Okay, so PG will be substituted as G here, and we have to perform left rotation on this node G. And when we will perform left rotation on this node G, so you can see that this node number 2 is carrying left subtree also. Okay, please watch the complex rotations in my channel to understand that what will be happen. Okay, so this is the left rotations performed here. So this is the scenario that we have to perform left rotation on this node X, and X is carrying one child in left. Okay, that is alpha. So please compute first in order. When we have computed in order here, okay. So left rotation means we have to place left of its right child. Okay, so X will be placed, X along with its left subtree will be placed at the left side of its right child Y. So the right child of X is Y, right child of X is Y. So X will be placed at the left side of its Y. Now if you see that alpha and beta, so obvious that alpha value will be less than beta. So when we will place this X node in left side of Y, so the beta part will be at the right side of X. Okay, so the in order will be maintained after rotations also. So this is the left rotation which is performed if any node containing left subtree. So in the example part, when we will perform left rotation on this node number 2, which contain one left subpart here. Okay, so this node 2 along with its left part will be placed at the left side of its right child, which is 7. So when we will put left side of this node 7, left side of this node 2 and 1 as a left side of means when we are putting this node number 2 and 1 to the left side of this node number 7. So when 2 1 will be placed at the left side. Okay, so we can see that 5 is greater than 1 here. 5 is greater than 1. Please watch. Okay, alpha and beta here. Okay, so when X is placed at the left side of Y, then alpha and beta will be children of this X. Okay, so alpha is less than beta, so alpha will be placed at first and beta will be placed after. So this is the scene here. After performing left rotation, 2 will be placed at the left side. Okay, and 8 is right child, so we will put 8 as right child. 2 and 1, so in the 5 will be sibling of 1. Okay, and 5 containing 4, so that will be placed here. So this is the left child rotation. So this is case 2, and now this is node G. Now again check that its parent P of G is red. Okay, so this is node G, its parent P of G is red, and uncle of this node 2 is black. Now this G is left side of its parent. Okay, you can see that G is placed at left side of its parent. Okay, so while the color of PG is red and the color of uncle is black and Z is placed at left side of P of G, then it is case 3. Okay, so what happens in case 3? So when when G is left child of its parent and P of G is red and uncle of G is black. Okay, so we have to set P of G as black and G's grandparent PPZ as red, and we have to right rotate PPG. So we will perform it. Okay, so the parent means PG will be black, P of G will be black, and we have to color grandparent as red, and we have to perform right rotation on PPG. So what is the right rotation? It also contains the right subtree. Okay, so it again there will be learning of complex rotations you can learn from here. Suppose we have to perform right rotation on this root node Y. Okay, and Y also containing right subpart. So what is right rotation? The node will be placed at the right side of its left child. Okay, so left child of Y is X, so Y will be placed at right side. When y will be placed at right side, then beta value will be less than theta. So beta will be left side and theta will be as it placed here. Okay. So when we will perform rotate right of ppg, so this 11, 14 and 15 will be placed at the right side of 7, and because we know that 8 is less than 11, so 8 will be placed at the left side of its 11. Okay, so these are all three cases where we can learn that how these cases are occurring and we are getting the balanced tree. So what is the meaning of balanced tree in able tree? That all the red node will have black children. Okay, red, both children of red node must be black, and black node may have red child or black child. Black black combination, red red combination, no matters here, and the black height property should be maintained. Okay, so please watch the RB properties, cases of RB properties, and one numerical example. And this was the this I have taken this example that you should and you have understood the cases. Thanks for watching.